These days, I'm pretty reliant on my favorite AI or LLM for a lot of tasks. As a developer, I tend to vibe code, so I'm using millions of tokens on the daily just to do my job. At the same time, our application now includes an AI-powered question and answer RAG feature, which users love. And those are powered with our own LLM since it's data that can't be shared externally. But what both myself and our users care about is speed of the AI model, and my boss definitely cares about the price of our AI bill. Now, what if there was a way to optimize the AI model we use so that it can perform twice as fast, but only use half of the hardware acceleration to do so? I know it sounds like magic, but enterprises have been using tricks like LLM compression and optimization for years, cutting down the need for extra GPUs while delivering faster AI apps for their users. And if you have a few minutes, I want to explain how this open source technology works and show you a demo as well. So let's imagine a new Llama model comes out. By default, it's released at an uncompressed and full weight precision like floating point 32 or integer 16, which provides great results but can be quite beefy to run ourselves. By using machine learning algorithms like GPTQ to quantize or to compress the model down to, say for example, integer 8, we can cut the model size down from originally 220 gigabytes to 55 gigabytes and only need 1/3 of the acceleration or GPUs in order to load and run this model. Now from the outside, you'll probably notice the speed and latency improvements, but behind the scenes, there's less computation needed as we're reducing the numerical precision of the model. Think double the inference speed while retaining up to 99 or 100% of the model's accuracy. There's a quite popular Red Hat AI Hugging Face page where we do this all for you for the leading model options from Gemma to Llama to Mistral, Quinn, and more. But since you've made it this far in the video, I'll give you a demo on how we make that happen using an open source tool called llm-compressor. So let's walk through how to optimize a model for inference using this open source library. So I've just hopped into the terminal here and we're going to install the llm-compressor as a library so that we can quantize and compress Meta's Llama 3.1 down to a floating point 8 precision. So first off, we're going to load it in and spread it across our two different GPUs. And then we're going to define a quantization recipe. So we're going to quantize only linear layers to floating point 8 so that we have faster and a smaller memory footprint for our model. Now we're also going to save this locally so that when we run this quantize.py, we're going to have this locally on our machine and we can do evaluations to it to make sure that it can still perform. We're going to be using the GSM task using lm-eval, another tool, to ensure that after we quantize our model, we still have that same performance and accuracy. So first off, we're going to test out the original model. And so once this finishes up, we'll see that it achieved a 88.93 on a benchmark. Now let's run that again to our newly quantized and compressed model. And with that original score of 88.93, let's see what this new model gets after we've compressed it. So as this finishes up, we're going to see that we've got a 88.17. So if we do the math on this, we can see that we recovered 99% of the accuracy of the model, but it is half the size of the original model and can now run faster with that lighter memory footprint and power our AI applications. So now you know how it works behind the scenes, but I encourage you to check out the Hugging Face library for these pre-optimized models that are ready for inference with a variety of different tools. So for example, if I check out some of these validated models, I can see the optimization that we've done, for example, quantize to int4, but I can also see how to deploy this with VLM as an example, but also with the Red Hat AI inference server, or deploy this on OpenShift AI. And of course, at the bottom, you can see the accuracy before and after we've done this optimization for you. So if you want to do this yourself, also check out the llm-compressor library on GitHub. But I really appreciate you joining us. And please be sure to leave a like if you learned something today. Cheers and have a good day.